Assalamualaikum and hi. Today our group will present about determination of caffeine in soft drink by using high performance liquid chromatography HPLC. But before we start, we are going to introduce ourselves. Hi, my name is Saidatina Nur Ajiba binti Rihi Amir and my metric ID is 2021239436.
Hi, my name is Nurul Atika binti Jamaluddin and my metric number is 2021 656 126.
My name is Muhammad Ushadi bin Sham. My metric number is 2021299154.
Introduction. Besides liquid chromatography, other type of chromatography used in laboratory is high-performance liquid chromatography (HPLC). The stationary phase column in HPLC is tightly packed compared to other type of liquid chromatography. This column is packed with C18 particles that are less than 10 micrometers in diameter. It is necessary for the particles in the column to pump the mobile phase through the column at very high pressure since the particles are so small. The pump will keep a precise flow rate so the position of the peak in time can be used to identify the species in the sample. It can be done by comparing the chromatographs of prepared standards so it can determine the particular species. The indication of the standard is the common thing. So for the objective is to identify the presence of caffeine in the soft drink sample and to determine the amount of caffeine in the soft drink sample. For the material, the instrument that we use is isochromatic HPLC system with UV detector C18 column. And for the chemical, we use caffeine, methanol, HPLC grade, double distilled water, and soft drink sample. For the apparatus, volumetric flask, filter paper, shrink.
Next, for the procedure, for the preparation of caffeine standards. Firstly, standard caffeine samples of 20 ppm, 40 ppm, 60 ppm, 80 ppm, and 100 ppm were prepared by diluting portions of the 1000 ppm solution with distilled water. The volume needed was calculated from the 100 ppm caffeine stock for all dilutions by using the dilution method formula, where M1 V1 equal to M2 V2. M1 is for the initial concentration in ppm, V1 is for the initial volume in milliliter, M2 is for the final concentration in ppm, and V2 is for the final volume in milliliter. Secondly, all flasks are labeled accordingly. The next step is preparation of soft drink samples. Firstly, a soft drink sample was obtained. The sample was degassed by placing it in a vacuum flask, and the flask was connected to a vacuum pump or water aspirator. The sample was left under vacuum until no bubbles appeared in the soft drink samples. Lastly, the gassed soda was filtered through 42 filter paper. The last step is preparation of HPLC for samples testing. After the serial dilution and sample were prepared, the instructor briefed on standard operating procedure of HPLC to run all the standard solutions and soft drink samples.
Going through the results of our experiment, we have compiled all of the HPLC analysis into one table. From the concentration, we have 20 ppm, 40 ppm, 60 ppm, 80 ppm, 100 ppm, and we have unknown sample. So from the retention time we received, we got 2.423, 2.341, 2.339, 2.312, 2.296, 2.290. The retention time we received, so we can compare the standard peak of the caffeine. Based on the area of the week, we receive 300,000, 600,000, 900,000, 1.3 million, 1.7 million, and from the unknown sample we received 600,000. Based on our results, by comparing our area of the weight, we know that unknown sample has 40 ppm concentration. Going through the discussion, from our objective, we want to identify whether caffeine is present in a soft drink sample, and we want to determine the amount of caffeine in the soft drinks sample. So at the start of our experiment, a series of standards with no concentration were drawn through the HPLC instrument, that is 20 ppm, 40 ppm, 60 ppm, 80 ppm, and 100 ppm. After that, the retention time along with the area of weight were recorded in the tables. Both of the data was used to determine the standard compound of caffeine, and we want to determine the concentration of soft drink samples. The unknown sample was run through the HPLC instrument and discovered 3 peaks. All of the peaks are recorded from the HPLC analysis. By using the standards of retention time we received earlier, we managed to find a peak compound similar to the standard compound. By comparing the area of the wick from the unknown sample with the area of the wick from the standard sample, we found that the unknown sample is similar to the 40 ppm concentrations area of the wick. So we were able to identify the presence of caffeine in soft soda drink sample.
This is the end of our video. In conclusion, we managed to identify the presence of caffeine in soft soda drinks by matching the unknown sample compound peak with the standard sample compound peak. We are also able to determine the amount of caffeine in soft soda drink sample, which is 40 ppm concentration.